Alright guys, so let's get into Chapter 10, which is all about behind the scenes software programming. So we're going to talk about something called the system development lifecycle. Okay, we're going to talk about the program development lifecycle. We'll talk about how programmers construct a problem statement from a description of a task. Okay. We're going to talk about how programmers use flow control and design methodologies when developing algorithms. Talk about the categories of programming languages, the roles of the compiler, and as well as the IDE, which is our integrated development environment when we're coding. Okay. Talk about the role of debugging in program development. Talk about the importance of testing and documentation when you're writing code. Okay. Talk about the driving factors behind the popularity of various programming languages. Talk about the considerations in identifying an appropriate programming language for a specific setting. Compare and contrast modern programming languages. And finally, we will talk about some key principles in the development of future programming languages. Okay, so every day we face a wide array of tasks. Some tasks are complex, okay, and these tasks require creative thought, and they require a human touch, okay. But some tasks are candidates for automation with computers. Okay. This automation is actually achieved through programming. Okay. Tasks that are candidates for automation include tasks that are repetitive, those that work with electronic information, and those that follow a series of clear steps. If you choose to pursue a career in programming, there are a lot of advantages to this particular career path. All right, there are a lot of jobs that are open right now. Okay, the salaries are usually pretty great. Telecommuting is often pretty easy to arrange. Again, I mean, this depends on your employer, but a lot of times they'll let you work from home. Okay, maybe you don't start out doing that. You actually, go to the office and work there. But after you've sort of proven yourself, a lot of times, yes, they will allow you to work from home, even if like part of the time. Okay. If you can't find like any sort of existing software product in order to accomplish some kind of task, then programming is mandatory, right? You got to come up with a program that's going to be able to do this task, okay? So having a basic knowledge of programming enables you to add features that support your personal needs. If you plan to create any sort of custom applications from scratch, having a detailed knowledge of programming is going to be critical to the successful completion of your projects. So let's talk a little bit about something called the system development lifecycle. Okay, or your SDLC. Generally speaking, a system is a collection of pieces that are working together to achieve a common goal. Okay, so like take your body, for example. Your body is a system of muscles, organs, and other groups of cells that are all working together. An information system includes data, people, procedures, hardware, and software that help in planning and decision making. Information systems help run an office, they help coordinate online purchasing systems, and they're what's in the background behind database-driven applications. Things that are used by Amazon, for example, or Netflix. There are 6 steps in a system development life cycle model. Okay, so here's the model right here. Oops, sorry guys. Okay, right here. So let's talk a little bit about these steps. First of all, corporations form a development committee in order to evaluate proposals. Okay, so what is the problem and how are we going to, do something about it? Okay. Analysts explore the problem, develop a program specification, define user requirements, and then they go ahead and recommend a plan of action. A plan using flowcharts and data flow diagrams helps programmers. Program development begins next. So there's a lot of stuff that happens before people actually start programming. Okay? Testing and installing the program to ensure that it works properly. Okay? And then program performance is monitored in order to determine whether the program is meeting the needs of the end users. And when I talk about end users, I'm talking about people like us, people who actually use the software. Programming is the process of translating a task into commands that a computer uses to perform the task. Okay? So program development lifecycle is just the process of moving through the stages that a project goes through, from development all the way through deployment. And deployment is when we release the software in order to be used by the public. The problem statement is the starting point of programming. So what is the problem? What problem are we trying to solve here? Okay. It provides a clear description of the tasks that are to be performed, and it also helps the programmers understand goals of programming. The goal of a good problem statement is to have programmers interact with users in 3 areas. So data is just known as the raw input, okay? Information is the result, and then the method is the process of converting inputs into the expected outputs. Okay? So when you come up with your software idea, you have to, realize, like, what do you want to come out of it? What output are you expecting, right? So that's part of of your problem statement. Programmers also have to describe what the program should do if the input is invalid. Okay, and we refer to this as error handling. So I know this is sort of technical if you have never talked about this kind of stuff before. A lot of times, at least what we're referring to as far as what to do if the input is invalid, okay, is, say you're writing a program, even a simple little program, just writing out, say, hello, what is your name? And so you set your program up to wait for your user to type in their name, and then it will, maybe the output that you want it to do is to say hello so-and-so, whatever the name is that they typed in. Okay. What if someone types in some numbers? Okay, that's an unexpected input, and so you have to, as a programmer, be prepared for all kinds of inputs that aren't expected. And so, because it happens all the time. Okay, and so you have to include some stuff in your code that can handle those types of errors. So that way your program doesn't just say, oh my gosh, I don't know what's happening, and your user is like, this is the worst program ever. Okay, so the testing plan, it can't list every single input, but you can identify, as a programmer, categories of inputs. So things that we call strings, okay, would be like your letters. So the letters of a name might be your expected input. Instead, you might end up with numbers, which we call, ints, like short for integers, or floats, which are decimal point numbers, okay? And basically, you just sort of have to address those probable errors and then specify what kind of output you want to be generated. Algorithm development. So this is a huge part. This is like a major part of software engineering. Okay, an algorithm is just a set of steps that describe what the program must do to complete its task. Okay, if you want the most common example of an algorithm, look at a recipe. Like, yes, a recipe as in to cook food. Okay, a recipe is an algorithm. It tells you what to do step by step. When we use algorithms in our programming, or when we come up with algorithms, basically we are telling the computer what to do step by step by step by step by step in order. Okay. Algorithms are limited, and they're often represented through flowcharts. Okay, and the reason we create these flowcharts is just to have a visual representation of the patterns, because we use a lot of patterns in coding. Okay, and then we also have something called pseudocode. Okay, and pseudocode is a text-based approach to documenting an algorithm. So it's not actually code. It's sort of like the English version of what your code does, what your algorithm does. Complex problems involve choices. And so your algorithms include these decision points, right? Binary decisions are questions that can be answered in either yes, like true, or no, okay, false. Okay. So we're looking at this right here. This is our decision point. Okay. Loops are when a question is asked. So if the answer is yes, then actions are performed. So in this diagram here, we're asking our user to input the number of hours worked. Okay. Our program then reads the number of hours that are worked. Okay, and then we continue on here. Okay, this is a flow chart, by the way, and so this is the number of hours worked less than or equal to 8? If the answer is yes, then do this. If the answer is no, then do this. Okay. So once the actions have finished, the question is asked again, creating something that we call a loop. Right? When the answer is no, okay, the algorithm moves to the first step that follows the loop. And this is really hard to convey via an online course where I'm not actually seeing your faces and being able to sort of write along like on a whiteboard to explain better to you what I'm trying to say here. So I apologize in advance. The initial value, okay, these are just terms here, is the beginning point. You have a set of actions that will be performed inside your algorithm, okay, and then a test condition, which what it does is it checks to see if your loop is completed. Okay. Control structures are keywords in a programming language that allow the programmer to direct the flow of the program based on a decision. So if you guys can, please read Chapter 10 to get a better grasp on this. I don't want to put up 4 hours of lecture because we all know that you will not listen to it, okay? So definitely read the chapter in order to get some more in-depth information. Okay, still talking about algorithm development, okay? There's different design methodologies that people follow, okay? But one is a top-down design. Okay. So what happens during this is a systematic approach in which a problem is broken into a series of high-level tasks. Right? In the top-down design, programmers apply the same strategy repeatedly and breaking down each task into successively more detailed subtasks. This continues until we have a sequence of steps that are close to the types of commands that are allowed by the programming language that you will be using in order to write your code. So all of these things are done before you write your code. Okay? So when you think about a software engineer or a software developer, all the different terms for the same job basically, there's a lot more to it than just coding. Okay? You don't just spend all of your time writing code. You work in a team, you work on all kinds of different things before you actually start coding. Top-down design is an approach in which, again, a problem is broken into a series of high-level tasks. Okay, so in this figure, you can see a top-down design is applied to the highest level of tasks, okay, in this parking garage example. And just as a quick fact, this parking garage example that's in your book is actually an interview question that's asked a lot. And if people can't answer this interview question, these are technical interviews, they are scratched off the list of people who are going to get the job or not. Okay, so applied to the highest level tasks in our parking garage example. All right, this one is about working here and the how many hours they worked in the parking lot. The tasks are further refined into subtasks, and then the subtasks are refined into a sequence of instructions.